Good morning. Uh, I'm Dennis Wingo. I'm the CEO of SkyCorp Incorporated, and we work in the realm of on-orbit servicing, manufacturing, and in-space services. And we're trying to do something today to help inform people of the promise of near-term space, how it pertains to our lives, and even more, how we can use it and how we can economically develop it and create an entirely new ecosystem of business in space. And today I have with us, and this will be shown at the TechCrunch conference that's going on today, December 15th, 2021, as well as beyond. And we have with us today Dr. Gordon Roesler, and I've known Gordon a long time. Former DARPA program manager and many other hats he's worn over the years. But Gordon is one of the world's foremost experts in the area of on-orbit servicing, in-space manufacturing, in-space assembly, and in-space logistics. And in a previous interview, we had Lieutenant General Stephen Quast talking about things at the high level. And here we're going to delve into some of the more detailed aspects of it and where Gordon kind of thinks things are going. And so Gordon has a background in both the commercial and the DoD side, so he has a very good perspective on this. And so, Gordon, Dr. Roesler, I'd like to welcome you and just say hi.
Thank you for the exaggerated compliments there, Dennis. That was really over the top. I have been working in specifically on-orbit servicing for 20 years now. It's amazing how time goes by. But we're at a moment here in history where we can create a whole new sector of the economy by exploiting all the technologies that have just come to fruition in the last few years. And we even have examples on orbit now that are working that prove that this isn't science fiction anymore. So thanks for having me, and looking forward to chatting.
Gordon, building on that, we do definitely have something on orbit today. It's called the Mission Extension Vehicle. It was developed by Northrop Grumman with a little help from us in the background. But you also very much were involved, and it's getting ready for deployment here in the next couple of years. A system called RSGS for Reusable Geosynchronous Servicing and
Robotic servicing of geosynchronous satellites.
There you go. Okay, so good acronym. So kind of tell us about what your thoughts are and how you were going when you were a DARPA program manager with RSGS, where it is gone, and how you would compare the MEV, because what we would like to do, we want to get into some of the details and the businesses and the ecosystems that are created. Kind of give us your views.
Let's go back 20 years. DARPA had a program that was being put together then called Orbital Express. It was going to do automated docking of a servicing vehicle with its customer satellite, module replacement, refueling, all on orbit, all automated. And I proposed to the DARPA director, I said, well, that's great, except to take advantage of those services, you have to change the design of a satellite so that it's modular, so that it can accept. So it has a standardized interface for the docking. It can accept these new services, standardized refueling interface. I said, what can we do for satellites that haven't been modified for refueling? So we very quickly settled on the fact that you need multi-jointed robotic arms to do that some of the operations need to be automated for safety. And we chose GEO. We chose geostationary orbit. Why? Because it's the boardwalk in the game of space monopoly. It's where the money is. There's 300 satellites out there, $120 billion a year in bits go out to that orbit and come back. So we said, and by the way, some of the highest priority military satellites out there too. Nuclear command and control satellites, missile launch detection, things that keep us safe strategically. So that was where we decided to go. Way back in 2002, we started working on proving the concept in the laboratory. Then we built a space-qualified robot arms, and now there's a flight program that started in 2016, then should launch in 2024. It'll go to GEO. It'll be owned and operated by Northrop Grumman's Space Logistics subsidiary, and it'll be a completely commercial entity. So they are operating their mission extension vehicles now. They're getting revenues from extending the life of a satellite. RSGS is going to add 4 new capabilities to that constellation, if you will. It's going to add ultra close inspection with the cameras on the end of its arms. It's going to add orbit repositioning. It's going to add repair. So every couple of years, a solar panel doesn't fold out right, or an antenna doesn't fold out right. Very small forces can probably correct those anomalies. So, and it will be able to attach modules to existing satellites using either a clamping mechanism or a hot melt mechanism, both of which have been tested in the laboratory. We know they can do this. So we're expanding the set of capabilities that can be brought to that particular orbit, geosynchronous orbit. And then there are other orbits that, as we develop and as we invest more, we're going to be able to support those as well.
Yeah, well, Gordon, I'm going to kind of go into a little bit of inside baseball here because you and I have been interacting in this area since at least 2002, 2003. And when I very first came to you, when you were a DARPA program manager, we had a company that we called Orbital Recovery, which we were looking at doing the life extension mission. And today, we eventually sold that patent to Northrop Grumman, and that is the basis for the MEV. Well, our philosophy at that time is that the commercial business was a little different than your DoD because, and I sat in the office with Fred Kennedy when he tried to give that away, the Orbital Express away to NASA, and they couldn't take it. And we were using Orbital Express at the time as the example of on-orbit servicing because it was a great engineering and science experiment, but it was not commercially viable. And this was also our complaint about RSGS in the early days. It's now moved in a much more commercial direction. And
only because you didn't understand.
Yeah. Tell that to Al Tedros. And so the really nice thing, and you have a point, but the world has started to catch up with both the ideas that we had with life extension as well as in-space servicing. And that's what the TechCrunch conference is about, moving in that direction. And so I think this is a theme for us to explore, is that the world has changed since we both...
Yeah. I mean, let's face it. We're getting a lot of questions in the servicing community from people who said, look at these mega constellations. Why would you bother to service anything? Those satellites are so cheap, just replace them every now and then. My counter argument is broadband.
Yeah.
My counter argument is broadband. If you look at the growth rate in demand of broadband, it's going up 26% a year.
Yeah.
What that says to me is that there is no single system. There is no orbit. There is no communications means by itself that will keep up with that demand. Fiber, LEO, GEO, microwave, cellular, laser, all of them are going to be stressed to keep up with that. So the designs and the missions of GEO satellites will change, right? They may have a lot more utility in linking to LEO satellites than they do broadcasting the ground. I mean, these things are still being worked out. 5G is going to play a role, and we don't understand what that is. But that demand for broadband means that everybody can profit as long as they develop the technology to address it.
Absolutely, and again, to go to this theme that the world has changed. In 2002, 2003, yeah, we had the internet, we had e-commerce, but like you say, it's exploding. Video demand is driving a lot of that, so many of the LEO constellations were predicated on low latency, but nobody cares about low latency in video. So this is why Viasat just bought Inmarsat. This is why the GEO business is not going to die. It's going to grow, but this... Go ahead.
They bought them so that they could link these constellations at different altitudes, with specialized missions, and the whole is more than the sum of the parts when you do that.
Right. So now let's think about this a little broader in terms of the different orbits. Now, the LEO business right now, NASA just gave these commercialization contracts for space stations, commercial space stations, to be the successor to the International Space Station. We just delivered a payload to the International Space Station for technology development. But let's look a little bit beyond. Where do you see the opportunities in servicing, assembly, manufacturing, beyond just LEO GEO towards cislunar space, the moon, and let's call it the entire cislunar, which means between the Earth and the moon ecosystem?
And you left out logistics,
Yeah.
which is the first cousin of servicing. But let's think about this. So in LEO, commercially, you're going to have commercial space stations. You know, you're going to in GEO, you're going to continue to have satellites of some number doing some missions and that sort of thing. In cislunar, you're going to have the gateway. The commercial space stations are going to need towels. They're going to need food, right?
Yep.
And when you talk about, like, for example, the gateway, NASA has a contract with SpaceX to provide logistics. But what if you want out of sequence deliveries? What if there's an emergency, some electronics, some medical equipment, that sort of thing? So think about a logistics network that connects all these places together, right? That, for example, in Blue Origin's announcement about their recent NASA award, they mentioned the fact that there's going to be a last mile space tug in there to help catch dumb payloads that come up that don't have RPO capability, that will take those payloads the last mile for safety and then bring them to the stations and that sort of thing. I've been advocating for that for a long time. It's kind of a mini RSGS. Its job is just small orbit transfers. You're going to need the same kind of technology near the gateway. You're going to want to. The point is, let's think about logistics first, right? My example that I always use is Amazon. Jeff Bezos did not have to create a logistics network in order to become one of the world's 5 largest companies. It already existed, right? He's now adding to it with his own trucks, but he had FedEx, he had UPS, he had the postal system, right? When there's a logistics system, people figure out how to use it.
Right.
And then think about any given space startup that you can think of. Lunar mining, commercial space stations, persistent payloads, orbit outposts, and that kind of thing. Every one of those people, every one of those programs is worried about, do I have to provide the logistics as well?
Yeah.
If we create a single logistics system like your orbit logistics vehicle that can go to GEO, that can go to cislunar, that can go to MEO, then everybody can breathe a sigh of relief and say, okay, I'll concentrate on my technology and my specific thing, like converting regoliths to oxygen or whatever, but I know there's going to be a transportation system there, and you are one of the few that's actually thinking along those lines and addressing that need. So let's get the logistics stuff going first, and it'll support everybody.
Absolutely, and in that regard, and everybody uses SpaceX and Blue Origin and all, but it's not just about the megacorps. It's not just about these companies, like the future of the expanse, the solar system's controlled by a couple of corporations.
The small companies,
Yeah.
the small companies are going to benefit more from the existence of the logistics system than the big companies.
Exactly.
They have fewer resources that they can spend on launch or on in-space transportation and that sort of thing. If all they have to do is pay a fee to get something moved from orbit A to orbit B, that's a win for them. So this is really going to help with entrepreneurial space activities.
Yeah, so let's kind of talk about let's call it the confluence of commerce and national security. I go to, and I always love historical analogs. We used to use a term over 150 years ago when you had these forts way out in the wilderness in the West and all, and we re-provisioned. And so what this means is if there's someone who's out there, this is where the logistics play really comes in to create this ubiquitous operations in cislunar space that we call it. Where do you see this evolving in the next 10 years?
So there's a great quote, and I won't get it verbatim, but it's from a Navy Rear Admiral who was looking back on the logistics, huge logistics effort that we had during World War II and during the Korean War. And he said logistics is the interface between the military forces and the economy of the nation. You've got to think about both of those things if you're going to get logistics right. So the Space Force wants to be able to maneuver much more aggressively than they do now without limiting the life of their satellites. They're going to need propellant, right? Well, the commercial guys are going to need propellant too. And recently, the White House has decided that they're going to go big after debris removal.
Yeah.
That's very propellant intensive. So the civil, the commercial, and the military are all going to need propellant, which is probably going to be, in my guess, the first real commodity that the Space Logistics Network is schlepping around, right? I see it. Then there's going to be, things like electronics upgrades. Then there's going to be things like repair. NOAA is very interested in the ability to repair satellites. I mean, the primary sensor failure in GOES 17 was a tremendous, embarrassment problem. I mean, they want to be able to improve the continuity of meteorological observations. So repair parts is another, and you have to build the satellite so it can be repaired, of course. And this is a lot harder than just tweaking a solar panel to make it come out. But
Yeah, well, you bring up an interesting point there, and you have the historical analog to World War II, which was a logistics war at the end of the day. And the number 2 man in the entire U.S. government in logistics in World War II was a General Electric chairman of the board, Ralph Cordner. In 1960, there was this event put on by Simon Ramo of TRW fame to talk about that, and Cordner, who had literally been the number 2 guy in this entire World War II logistics, said the government is not the way to go in government-directed space. Now, you and I both have gray hair, and we saw many of the things that we talk about now abortively discussed and funding died in the 70s and 80s and 90s. So today, investment is really going, the Defense Department knows that the old way is not working anymore. If you were talking to an investor and giving an investor advice right now, where would you advise them to put money and for the maximum, let's call it leverage towards building this logistical ecosystem?
Well, first, let's talk about what I would say to a government policymaker. Right? I would say there are 3 roles the government can play that are helpful in creating, in-space servicing and logistics and all that other stuff. The first is keep up the R&D, right? Because it's the government entities, the Naval Research Lab, the Air Force Research Lab, that have made a lot of advances in these areas, which then get picked up by industry. Right, so keep up with the R&D. The second one is come up with some seed funding. Don't the logistics, the servicing, all that sort of stuff should not be a government-owned entity. That's like the post office, right? Not a good idea. But seed it, just like NASA did with the COTS program, right? Put some money out there now, and then the third thing is to announce yourself as an anchor customer. Say, government, I want to use this. If you will build it, we will definitely come. Here are the missions we want to refuel. Here are the electronics boxes we want to replace on GPS outlets, whatever. So those are the 3 government things. Now, once that happens, I would say to the investor, when that seed funding shows up, you should follow it, right? Yep. Because you now have this non-dilutive capital. You have a customer there that's highly motivated and this sort of thing. And we're on the verge of this happening, right? So this is where I see now, and waiting for that before the the big government reveal or whatever should it happen. I mean, it's hard to say what's going to happen right now. We can't even get a National Defense Authorization Act passed. But I mean, presuming that we move forward from that, the government says they're interested in debris removal, so there's going to be investment there. Yeah. That's a good place to invest. Private sector I mean, and you've got a great vehicle for doing that too. You add a couple of robot arms on it,
Yep.
and you know you're highly efficient, right, with your xenon propulsion, with your propulsion modules and that sort of thing. Um, you're low cost. You have an innovative way of getting it up there and getting it assembled and all that sort of thing. So this is an area. Um, follow the government's lead on the debris removal thing, because they see debris removal is not a profit making
Right.
proposal, right? But the good thing is, if we go that way, the technologies that are used for debris removal are also going to support the logistics network. They're also going to support servicing, assembly, manufacture. So those are the places where I would say an investor needs to keep their ear to the rail. Right?
Yeah, and you bring up a great point there. It wasn't just what NASA did in some of the early days. And I just read about this recently, that in the early 1930s, the first all metal, single wing, multi engine airplanes, multiple of them, it wasn't just Boeing, but there was Boeing, Lockheed, Consolidated. Many companies were paid to build these airplanes. Some of them ended up being the B-17, one became the B-24 Liberator, fighter planes. All of the things that we look so fondly at World War II were originally seed funded by the government and then went into commercial service before the war.
Yeah, I mean, the airmail thing is another example of that, right? They saw, well, you know, this aviation thing looks kind of interesting, but we don't really know. But we can cook up something. We can invent this thing to give them a market called airmail. Right now, we don't have to invent any markets in space. There are plenty of things for on-orbit servicing to do, plenty of things to assemble in space, plenty of things to manufacture. That's not. We don't have to question whether or not there are markets. That's the difference really with airmail. But many of those are going to struggle if they don't have the logistics backbone to support.
Right.
And if they don't have the digital side, the communications backbone to support them as well. So this is another important thing, is we need to provide ways to link all these guys together. There is an effort called ComStar right now, very interesting, and that's mainly for linking things together that are on the moon. But it's a huge laser pipe coming back from L1 to the Earth. These are the kind of things we need to think about. How to link together our other assets in order to fully develop this new sector of the economy.
Great. So, in closing here, what I would like to ask you is that everybody is eagerly anticipating the first flight of Elon Musk's Starship. And in talking with General Quast, that's almost like our Kitty Hawk moment. Looking into the future, past the Kitty Hawk moment, how do you see the Starship doing this utter transformation of in-space commerce that many of us, you and I, think is going to happen?
Think about a large cargo ship, container ship, right? 10, 15, 20,000 containers, like the one that got stuck in the Suez Canal, right? Those go from port to port. They load up at a port, they discharge at a port, but those goods are not just for that port, right? They're going to go all over the continent of that destination port. Starship, it looks to me like that. The ability to get 100 to 150 tons in LEO at low cost is amazing. Just like there is no cheaper terrestrial transportation system than cargo ships, right? There's nothing to compare to those. But what we need is, okay, here's 100 tons of stuff. It's got to go different places, probably, right? So the logistics system, so I look at Starship as a natural customer for this multi-orbit logistics system, so we can make the most efficient use of this amazing transformational vehicle, and that supports all these activities, all these new concepts, whether it's cislunar or or Geo or wherever.
Lunar surface.
If they're not getting stuff cheaper, we have these reusable in-space vehicles, right? So Starship is reusable from Leo down, right? Between the Earth and Leo, it's reusable. Then we have vehicles that stay in space, like yours, deliver things, come back, get another thing. So it's the same kind of reuse as Elon has been demonstrating with his Falcon 9 first stages, and is soon going to demonstrate it with his Starship second stages. We need to keep those, call it a third stage or whatever, in orbit, like yours, right? That schlep things around. So that's my vision. It's we're going from a situation where one rocket delivers one payload to one orbit to now a highly efficient large rocket brings a bunch of stuff outside the atmosphere, and then we take it the rest of the way with other vehicles. I think we're going to find that is amazingly transformational. It's like a catalyst for the space economy suddenly becoming so big we couldn't even imagine.
Yeah, and these were the things that we dreamed about 40 years ago when we all first got started in this, and this is what we had hoped the space shuttle was going to become, that didn't. But I really do think we're on the cusp of a new age, the true golden age of space, and I'm glad that we've lived long enough to still be a part of it. And I really, really, really appreciate your efforts in this area and what has been done to bring this about. Do you have any final thoughts that you would like to convey to folks, especially in the investment and in the, let's call it the business community, of where we want to go now for the most effective use of Starship and beyond?
I think it's simple. Don't think of space anymore as something that's so different from other domains of investment, other domains of human effort, that it frightens you. Starship allows us to think of space the way we think about terrestrial logistics, right? And so using the same disciplines that we use in terrestrial logistics, planning, scheduling, customer outreach, forklift drivers, longshoremen, all these kind of disciplines, they're going to come about in space. Some of them will have to be automated. And so there's an area of investment, is like, how do we automate the last mile thing or whatever, and invest by looking at terrestrial analogies and say, okay, that makes sense to me because it looks like what they do at the Port of Los Angeles, right? That I would say is the way to think about these things going forward.
Cool. Well, Gordon, thank you so very much for joining us today. We're going to be uploading this for TechCrunch, and then we're going to be putting it out on YouTube, because what we want to do is that, and this is what I talked to General Quast about, there's this argument by some, we don't need to be doing any of this stuff. That's all in the future. We need to pay attention to the Earth today. But it is, I know, mine and your thesis that by going out in the economic development of the solar system, that is going to be the way that we truly help save the Earth. Do you have any, just really, really concise final thought in that area? And then we'll go on about our day.
It would be a lot easier to take that laissez-faire attitude if we didn't have a strategic competitor, China, right? With seeing how aggressively China is going after every aspect of space, lunar development and anti-satellite weapons and all these sorts of things, we must do this in order to protect our security, in order to protect our economic well-being. Otherwise, we're going to be a vassal state.
Absolutely. And with that, Gordon, thank you, sir, so very kindly. It is always great to talk to you, and we'll see you soon.
You as well. Take care. Bye-bye.